Welcome to this presentation on one of the outcomes of the European project CERT. The part of the project CERT which this presentation is about is D3.1 with the title Towards a Converged EPB Calculation Methodology using the set of EPB standards. And my name is Dijk and I have prepared this presentation. I am one of the experts at the EPB Center. My background is that I'm active in CEN and ISO, and I have been one of the initiators and developers of the set of EPB standards. And in the past, I have also been responsible for the development of the Dutch energy performance standard for about 20 years. We're speaking about the CERT EPB calculation methodology. This is a proposal for a Europe-wide converged calculation methodology to assess the overall energy performance of buildings, for information on the EP certificates, and for benchmarking and checking compliance with the minimum energy performance requirements. And the method itself is based on the set of CEN and ISO EPB standards with a converged set of national annexes to these standards. Well, these are a lot of terms. So the content of this presentation consists of the following sections. First, an introduction, then an introduction on the set of CEN and ISO EPB standards, and then explanation of the national annexes to the EPB standards, and finally some conclusions. But let's start by asking the question, why is it important to converge with respect to the energy performance calculation methodologies in Europe? Then we first look at the energy performance calculation methodology itself, and we can distinguish definitions, the actual calculation method, and for instance assumed outdoor and indoor conditions. And these three elements together, they determine the energy performance value, for instance kilowatt hours per square meter. And as you see, we included also the definitions, because if you change the definitions you also change the energy performance value. But still, you have an energy performance value, but it has no meaning if you don't have a scale. So you need benchmarks, reference values, to give a meaning to the energy performance value. And this implies that if you have a different methodology, you also have a different meaning. So if you change the definitions, you have a change in methodology, you have a change in the meaning, and the output cannot be compared. While certain differences are okay, if it's possible to make a conversion, for instance, if you have climatic data or primary energy weighting factors that are different, you could replace these by reference data, and then you could compare on the basis of these reference data. But in general, if a method is different, it cannot be compared. Okay, so what is the set of CEN and ISO EPB standards actually? Well, if you look, for instance, at the EPB Center website, you'll find a large number of documents. And here you see them all brought in, well, not even all, in a scheme. But these are not all needed for energy performance calculation. So in the next slides, we'll show the modular approach, different themes and different applications. So the modular approach is an approach that has been adopted from the beginning of the development of the set of standards around 2012, which enables to clearly distinguish the different topics. So for instance, you have 10 standards which deal with overarching issues on the overall energy performance. Then you have 16 EPB standards on the building itself. Then you have a number on heating, cooling systems and ventilation. and airflows. On domestic hot water, lighting and building automation and control, and in total this gives you 61 EPB standards, which is the current total set. We can also make a distinction in EPB standards regarding the themes. So we distinguished the following themes: on EP calculation procedures itself, on pre-processing, post-processing, EP measurement procedures, but also building system or component design procedures, inspection and others. For instance, economic evaluation procedures. Only the first three themes are relevant for the calculation procedures, and that brings us to 37 standards. As a next step, we can also look at the typical user of the EPB standard. So is it a standard that is typically used by an EPB assessor or system engineer, so to do the actual EPB assessment? Or is the standard that, for instance, is targeted to regulators or to product or component manufacturers or suppliers? And there are even EPB standards that are specifically made for the EPB standard writers, for instance, because they include reference procedures. So for the EPB assessor or system engineer, there are 25 EPB standards, and the others are for the other categories of users, and they will be disregarded in this selection as well. Now we come to the final selection, and that is on the application. So you have EPB standards for general application, but you also have EPB standards that are for special application, special technologies or special situations. And then you have EPB standards for general application, but which can often be simplified without a major impact on the overall energy performance. And if we then filter out the ones on general application, we have 10 EPB standards, and the other ones are 15. So the final selection is 10 EPB standards. And of course, again, we need a disclaimer that this final selection is for part arbitrary and depending on the situation. But we continue the work on the 10 selected EPB standards. So, which are these 10 selected EPB standards? So that brings us to the scheme of the overall energy performance of building calculations. And for that we use the pyramid, which we use normally as a simplified illustration of how these EPB standards are interconnected. So the overall energy performance of the building is the top of the pyramid, and in order to enable to assess this overall energy performance, you need to collect the energy use for the different systems, and the energy use can only be calculated if you know the energy needs for heating, cooling, ventilation, lighting and so on. And in order to calculate that, you need to know the boundary conditions and the input data. And the overall energy performance of the building is covered by EN ISO 52000 Part 1, the overarching standard, which gives you the aggregated values on the energy performance and the conversion to primary energy. But the same standard also contains the overall EPB framework, like common terms, the modular structure and so on. So you could say that this overarching standard is both the alpha and omega of the EPB calculation procedures. It's the overall framework, and it's also the final aggregation and conversion. These are on the calculation part. So we moved aside this pyramid to give room for the other selected standards. So here we have the 52016 Part 1 is on the energy needs for heating and cooling and indoor temperature calculation. And then we have several standards to describe the systems: heating, cooling, ventilation and lighting. So we have the single standard for the calculation of energy needs and temperatures, and also humidity. And we have selected as a highest priority for the systems the two ventilation standards on airflow and ventilation systems, also the standard on heat distribution and a standard on heat pump systems. And then we come to a next section, that is the standards on post-processing. And here we have two important standards. One EN ISO 52003 Part 1 with overall indicators, requirements and ratings, and then a similar standard on the partial indicators on the building fabric and needs, which uses the output of the calculation of energy needs and indoor temperatures. And then finally we have and these are for the EP certificate benchmarking and for checking compliance with minimum EP requirements. Then finally we have the standards selected on the pre-processing, and those are the one on the climatic conditions 52010 Part 1 and the European standard EN 16798 Part 1 on the indoor conditions. So as highest priority, these two have been selected. So here we have the final overview of the 10 selected EPB standards. So missing from the selection are several system standards on emission, boilers, chillers, etc. Also domestic hot water needs, light and lighting, PV production, thermal solar, etc. The justification for not including these standards is also because thanks to the modular approach, it is not difficult to plug in these standards, the calculations according to these standards, in the total set of standards, while these selected standards have many interactions and are also the most important ones for the overall calculation. So now that we have selected the most important EPB standards, the work has been done. No, actually not, and that's because each of the EPB standards allows for specific national choices. Each EPB standard contains a template for these choices in a normative Annex A, and also informative default choices which can be selected or can be replaced by others in an Annex B of the standard. So then you can make national choices either based on the default choices in Annex B or replaced in the national annex, which is a document annexed to the standard, or in national data sheet, which is the same as a national annex. These terms are often also be mixed up, but that doesn't matter. So the same as a national annex, but then presented as a national separate document, for instance, in the building regulations. And more info on this Annex A, Annex B approach can be found at the EPB Center and also in a webinar which is referenced at the website. So it's important to realize that a set of EPB standards is not a one-size-fits-all. There are many options to tailor to a national or regional situation, which accounts for differences in climate, culture, building tradition, building typologies, but also policy and legal frameworks. And here you find some examples of this, and this is taken from a recording of the webinar on this subject, and you find a link again at the EPB Center website. Just to give you an example of such a table in Annex A and Annex B of an EPB standard from EN-ISO 5216 Part 1, you find a table on the choice for the calculation between to do a calculation with thermal zones which are thermally uncoupled, so thermally separated, or thermally coupled, or so this is what you can adopt as a national method, one of these choices, or you can say in a country, for our country, both methods are allowed. And then you look at Annex B, and you see that in Annex B the choice has been made for all applications thermally uncoupled calculations. And this is quite an important choice. It's one of the important choices because it has a major impact on the calculation procedures, also on the software tool to be developed for these procedures, and maybe even more importantly because it if you require a thermally coupled calculation, it requires much more input data on the boundaries between the thermal zones, not only on thermal transmission but also on ventilation, and it's a question how reliable this information can be acquired. So if we now look at these 10 selected EPB standards, how much of these tables do they contain in total? Well, that's 238 of these choices. So again, that's quite a lot. So what we did for each of these tables, we characterized them into a specific type, and also for each of the tables we proposed a specific choice. So the choice is also specified and explained, and we also indicated links with other tables in the set of EPB standards, because in many cases a choice in one of the tables has an impact on the choice of another in another standard or another table in the same standard, so the total set of choices should be consistent. So in the next slides we present the categorization of the tables. So here you find 9 categories of these choices, whether it's an important factor for the calculation, whether it's critical for calculation tool development, or maybe less crucial detail, whether it's a policy choice or not, and so some of these choices can be multiple choice, so policy choice can be important factor or a less important factor, etc. Whether it concerns categorization of the types of buildings or spaces or services, post-processing, choice in references to other EPB standards, measured energy performance or others. So for the calculated energy performance of buildings, we concentrate on these categories, these first 6 categories, because the other ones are not relevant for the calculation. References to other EPB standards are relevant, of course, but we assume that all of the relevant EPB standards have been adopted, so that we have a fixed choice on that. But if we leave aside the less crucial details, we concentrate further on the important factors and on the critical factors for the calculation tool development, and then we can further on see whether these concern post-processing categorization or a policy choice. So for the 10 selected EPB standards together, we count 44 tables as important choice for the EPB calculation, and they are divided over these 10 selected standards, as you can see here in this pie diagram. And then it would also be interesting to look whether these concern all policy choice or post-processing, etc. So here you see that 5 of these 44 tables concern a critical choice for the calculation tool development. 26 are policy choice, 2 are about categorization for buildings, spaces or services, and 11 are on post-processing, so EP indicators and rating. And again, we need a disclaimer because this categorization and selection inevitably contains subjective elements. And now for the final part of this presentation, some examples of the most important choices. First, we look at the choices regarding pre-processing. So that concerns the specification of space categories. So for instance, to distinguish between office spaces, hotel rooms, classrooms, residential spaces, etc. But it also concerns, for instance, a choice whether an indoor car parking is considered as part of the energy performance calculation or not. Then which building surfaces are considered. So heating, cooling, ventilation, domestic hot water and lighting. And there you could come across the question whether outdoor lighting of the building is also included or not. Specification of the useful or reference floor area, which is important for instance, when you speak about the number of occupants per square meter. It's very important that you speak about the same useful floor area definition and specification. And of course, which is self-evident, the energy performance is if expressed in energy performance per square meter, kilowatt hours per square meter, it's very important that you use the same definition of the square meters. Also the specification of the perimeter of the building and which energy flows are counted. So what is called on site, what is counted as renewable, are questions that have to be solved in this area of the choices. And as we've seen from the previous slides, some choices are technical, others are policy related, and several choices are mutually related. Then on the pre-processing still, there's one choice which is very important also because it's linked to the next presentation, and more details can be found in the report which deals with the next presentation, report D3.2. The CERT proposal is that for the EP rating it's assumed that all services are present and adequately sized to fulfill the needs. So both for the heating, cooling system, ventilation, domestic hot water, lighting, etc. Which means that the calculated energy performance can be used to compare the buildings mutually and against benchmarks and EP requirements. So it gives an impression of the quality of the building and the technology used, and not about the size of the systems. But then, for the EP certificate, it is proposed to take the actual presence of the systems. This means that if a system is absent or undersized in the building or in part of the building, the calculated energy performance will be realistic and will be comparable with measured energy performance. But this will be at the cost of comparability with other buildings and also at the cost of thermal or other comfort. So in this case it's extremely important that indication on the discomfort is also given at this high level of the EP certificate to show that an probably over-optimistic energy performance is due to discomfort. Then examples of other most important choices on the conditions, the climatic data set, conditions of use. On processing, the calculation procedures itself, on primary energy and CO2 weighting factors, on hourly or monthly calculation procedures, and if you have a monthly method, the matching factor. dividing the building for the calculation into thermal zones, and specific other technical issues. And as you have seen from this strike through of the matching factor for the monthly method, we propose to adopt an hourly calculation method. So to choose the hourly calculation procedures, and more information and explanation can be found in one of the webinars at the EPB Center. And then you see here these asterisks, and these indicate choices that if these choices are different between the countries, there's no direct comparison possible, of course, but in these cases the output of the EPB assessment can be converted, because these can be replaced by other choices, and then you can use these converted energy performance output for comparison with others. Like you could convert the some price in US dollars into a price in euros to make things comparable. On post-processing, there are also some choices. These are subject of the next presentation, so I will not spend time on these. Which brings me to the conclusions. So the most important EPB standards for the calculation of the overall energy performance of building have been selected. From these, all 238 tables with national choices have been analyzed and categorized, and important links between the choices in the tables have been presented. For each of these tables, a proposal has been made for the choice with an explanation. Some of the most important choices have been selected for this presentation, and the result is an UCERT converged overall EPB calculation methodology based on the set of EPB standards. And you find the reports and more information in these publications, because the UCERT project is still ongoing. A final update of these documents is expected by mid of 2022. So this concludes the presentation, and that leaves me to invite you to visit the EPB Center website for all the information on the set of EPB standards, the tools, the webinars, short videos, questions and answers, etc. And thank you for your attention.